Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is paths from root with a specified sum. First of all, let us start by understanding the question. What does question say? Given a binary tree and a sum s, print all the paths starting from the root that sums up to the given sum. So basically, we are given a binary tree. So we will be given root of that binary tree. Okay, a pointer to the root node of that binary tree through which we can access the whole tree. And we are given a target sum s. We need to print all the paths starting from root whose sum of the nodes, okay, sum of the values of the nodes is equal to s. Okay, path may not end on a leaf node. Okay, so it may be possible that path does not end on leaf node. Okay, it is not necessary that the path ends on leaf node, but we need to print all the paths whose sum is equal to given sum s. For example, if sum is 8 and this is the given tree, then if I look here, there is one path that is 1, 3, 4. 1, 3, 4. This path sums up to 8. 1 plus 3 is 4. 4 plus 4 is 8. There is no other path. So my output is 1, 3, 4. If I look at another example, sum is 38. I have two paths. One is 10, one is 28. One is 10, 13 and 15. So 10 and 28 is 38 and 10, 13 and 15 is 28. So this is 28, 28 and 10 is 38. So these two paths I have written here. Okay. You don't have to read input or print anything. Your task is to complete the function print path that takes the root of the tree and the sum as the input and returns a vector of vectors. Why vector of vectors? Because it is a vector of vectors, means inside there will be vector, means it's kind of 2D array because every path will have multiple number of nodes. So each path will be represented by a vector and there may be multiple such paths. So it will be vector of vectors, okay, containing the paths that leads to the given sum. The expected time complexity is big O of n square and expected space complexity is big O of n, and the constraints are given here. So now if we think about solving this problem, so basically let's say we are given this binary tree and our target sum is 3. Okay, so basically we want to print all the paths starting from the root node whose sum is equal to 3. So here why I have taken this example is because in the question it is said that the path may not end at leaf node. Okay, so those cases will also be covered here and some other cases will also be covered here. Why? Because here the sum and the target sum and the key values can range from minus 10 to the power 3 to 10 to the power 3. So there can be negative values as well as 0. Okay, so in case you get the sum equal to the target sum at a particular node, even then you need to traverse down. Okay, because there might be negative and 0 values, which if you add up ultimately it becomes 0, negative and positive, and it again becomes equal to the target sum. So when you reach equal to target sum, you do not stop traversing. Okay, because here the node values are not only positive, it is negative as well. Okay, so in this example, if I look, what are the paths whose sum is equal to 3? One is this, 1 and 2. So my answer is 1, 2. Another is 1, 3 is 0. No, this sum is 4. Then 1, 3 minus 3. This sum is 1. 1, 3 minus 3, 4. This sum is 5. 1, 3 minus 3, 4, 2. This sum is 3 because 1 plus this 3 and minus 3 gets cancelled out. 4 plus 1 is 5. 5 minus 2 is 3. So I have 1, 3, minus 3, 4 and minus 2. This is another path. This is what I was telling. Okay, your sum is greater than the required sum. Okay, here the sum value is 4 at this level because 1 plus 3 is 4, but you do not stop here because there might be negative values as well. Now 1, 3 minus 3, 4 minus 2 is 3. 3 plus 0 is 3. So this is also another path. So you have 1, 3 minus 3, 4 minus 2 and 0. Also 1, 3 minus 3, 4 minus 2 and this is 0. This is another path. So you have 1, 3 minus 3, 4 minus 2, another 0. So these are the total paths which are possible. Okay, now how do we implement it? So basically I will call recursively a function in which I will pass the pointer to the root node of the graph and I will maintain the sum obtained till now, and I will also maintain the path till now in a vector. As soon as my sum becomes equal to the target sum, I will push that vector into my vector of vectors, that is 2D vector, and I will move further recursively and I will basically visit all the nodes until the leaf node. Okay, because further from the leaf node we cannot visit any node, there are null pointers. Okay, so this is how we will do it. Now let's look at its actual implementation. Okay, so if we look at the actual implementation, so I have been given root and the target sum. So first of all, I take a 2D vector answer and I take one vector p in which I will store the current path which I am exploring. Okay, and whenever my current sum is equal to the target sum, I will push this vector p into my answer vector. Okay, I will call this recursive function in which I will pass the root of the binary tree. This is my sum till now 0 because I have not added any value. This is the target sum, this is the answer 2D vector, and this is the vector in which I will store the temporary path explode. If I look at this recursive function, I have the root node, I have current sum value, I have target sum value, I have 2D answer. This is passed by reference, please make sure. And I have the vector p, which is the path explode till now. If root is null, if I have reached to a point where there is no node, then I will simply return. Otherwise, I will add the key value to the current sum. Okay, and I will push back this key value to my vector p, because this is the path explode till now. If the current sum is equals to the target sum, it means this vector contains one of the path which I want. So I will push answer dot pushback vector p, because this is one of the path possible, and I will recursively then traverse the left subtree and then the right subtree. Okay, so in this way all the generated paths will be pushed into my answer. Also, one more thing, here you see I am pushing back this vector into my pushing this root key value into my vector, but I am not popping it out during backtracking because there is no need. Why? Because I am passing this by value. So when it will recursively backtrack to the previous function, it will already take the another form. Okay, because this is passing by value, not by reference. So even if you do not pop out, it's fine. Okay, but this answer vector you need to pass by reference, because this was declared in here and you are returning it from here only. Okay, so I will explore all the nodes and then return the answer 2D vector, which will contain all the paths explode whose sum is equal to the target sum. What would be the time complexity? See, basically I am just visiting all the nodes, so time complexity must be big O of n. But you see here in my answer vector I am pushing back the vector p. Okay, now this vector p basically will push n elements. Okay, so basically you see this path will be pushed once, then this all the elements will again be pushed. Okay, so pushing one element takes n times. So pushing one element inside the vector takes constant time. So pushing a path inside a vector will take big O of n time at max if there are n nodes, and there are and there may be multiple paths. So this is one path, this is another path, in which 1, 3, 3, -3, 4 and -2 are common. Are you getting my point? So at max the upper bound can be given to this by n square. Okay, because here I am pushing back the elements and here there may be repetition of elements. Okay, so I can say that the time complexity is big O of n square, or you can think of this at like this. Okay, suppose this is the vector, you pop out all the elements of the vector and one by one push in the answer vector, right? So there also repetition will occur. And what will be the auxiliary space? The auxiliary space occupied here will also be what? Upper bounded by big O of n square. Why? Because here in your answer 2D vector, you might push same element multiple times because of because of repetition in different paths. Okay, so this is the expected auxiliary space, which is your answer vector, and this is your time complexity. Now let's submit this code. Okay, let's submit it. Okay, we have solved this question successfully. I hope you have understood the solution completely. Thank you.